Question 13. Now, this is a really good teaching question / learning question because it really is worded nicely for you to be able to understand the difference between the two different kinds of deviation that we have here. So be very, very careful with the language that you're reading. Great hints in this question. So data records show that the speeds of the cars at a particular location on a highway are normally distributed. Remember, we have to say that if they don't tell you how many people are in the sample or the number of people in the sample is less than 30. Okay, so with a mean of that, so that means that our population mean, I'm just going to start noting some stuff down, is going to be 98.7. And a standard deviation of 4.1. The speed limit at this location is 100 kilometers per hour. So that means our speed that we're going to be testing is 100. A police officer plans to record the speeds of 20, n equals 20, randomly selected cars at this location. Determine the expected number. Now, remember, to find the expected number of something, we do its probability multiplied by how many of them there are. So the expected number of cars in the sample that will be travelling within 1 kilometre of the population mean. Okay, so think about what we're finding here. It hasn't really asked you anything about the expected means of the rest of the data. It's just telling you of the mean data, how many people are within 1 kilometre of that. So, trickiest part of this is understanding what it's asking you. So it's actually asking me to determine the probability. Now, if I add and subtract 1 from this number, I'll end up with 97.7 all the way up to 99.7. So we're testing the probability that it is between these. Okay, now this doesn't involve the formula that you've learned in specialist. This is just going back to methods as foundational knowledge, which is totally something they are allowed to do. So normal distribution, because we've assumed it's normally distributed, NCD, because we're looking for probability. My lower is going to be 97.7. My upper is going to be 99.7. My standard deviation is going to be 4.1. And my mean is going to be 98.7. Okay, and that is what we're going to chuck in to our formula here. So execute that. Okay, and we end up with, there's my little thing. Now, I'm running out of space here, but I would be stating all of that stuff that you substituted in. I would state it so that the confirmers can see NCD and then what you've used. This, so I'd go lower, upper, you know what I mean, okay? The rest of it, the deviation that you've used, the mean that you've used. It'll just make it really clear and make sure you're getting all of those other little marks. So I've chucked it in. I've worked out that the probability that it is between these two is equal to 0.1927. Now, the next thing I'm going to do is I'm going to determine the expected number. So the expected number is going to be equal to the probability multiplied by how many are in the sample. So we're just going to go back to our regular run matrix to do that. 0.1927 times 20. Okay, so our expected number, God, this update has not panned out for me. Okay, 3.854. So therefore, we expect 4 people. Okay, that number will round up. So we expect 4 people to be caught out by this. Now, if you're thinking about where marks might be allocated for that style of question, you would get a mark for this rounding. You would get a mark for finding this as your answer, a mark for finding that as your probability, and actually, sorry, probably a mark for this and a mark for 4 people. They might award you half marks for getting the answer, but you're going to have to round it to make sure that you get it. They're very explicit in statistics about what they want for each of these things. Okay, so that was looking like how we look in methods. We were just looking for within 1 kilometre of it. Now, determine the probability that the mean speed of this sample will exceed the speed limit. So now we're testing the mean speed, not just whether or not a speed. And that's the difference. That's why we get to use the other formula. So now, determine the probability that the mean speed of this sample will exceed the speed limit. So we are testing that. Where's my little thing? If our speed limit is this, 100, there are 20 people in our sample, and we are going to be testing S. Now we're using our deviation, our sample mean deviation. So S is now going to be equal to 4.1 over root 20. Now we can work this out using the probability that X is going to exceed 100. That's what we're calculating here. So all I need to do is think about what this looks like as a diagram. There's my diagram. Now we want it to exceed 100. So there's 100. It's anything higher. So now our low is going to be equal to 100. Our upper is going to be equal to 1 times 10 to the power of 99. The deviation we're putting in is going to be this S value over here, 4.1 over square root of 20. And our mean is going to be the same as it was in the other one. Because remember, our sample mean and our regular mean are like the same thing, the population parameter mean. Okay, so now let's enter it in. Go across, go to stats, distribution, normal. Now we want to find a probability. So we're going NCD. I should note that down somewhere, NCD. So our lower is 100. Our upper is going to be 1 times 10 to the power of 99. Our deviation is going to be 4.1 divided by square root of 20. And our mean is going to be the same as it was before. Okay, so that gives me, where are you? All right, probability X 100 is equal to 0.0781. So if I round that, well, that is rounded. If I express that as a decimal then, as a percentage, that's what it is as a percentage. Okay, so we're happy with that. Now, if we're thinking about where those marks might be awarded, we're probably going to be going here, the 7.1%, and getting maybe this one is probably where they'd award the grade. Okay, now let's go down and do the next part. So there is a 5% probability that the mean speed of this sample will exceed K. We're looking at the mean speed of the sample, which means that we're using our funky formula for standard deviation. So standard deviation is going to be equal to this over the square root of the number of people in the sample. Okay, so the other things that we're finding here, we want 5% probability, so the area in here, to be 5%, that the mean speed of this sample will exceed K. So that's our K value there. Okay, so now we just chuck it back into our formula. So this time we've got our deviation. We've got this, which means we want to use intra. So exit, distribution, normal, inverse normal is what we're using. Okay, so this time we don't want it to be central. The tail is going right. Then we want the area to be 0.05. Then our standard deviation and our mean are going to be the same as last time. So, right, 0.05, S equals this, and our mean equals 98.7, and that gives me K equals 97.12 kilometres per hour. Okay, and that's your final answer. So, for that one, marks would be awarded hold on a second, this has gone different. Just checking my notes, something's gone wrong. So execute, let's just go back and double check. And I have put these in the right places. Let's double check that mean. 4.1 divided by the square root of 20. Execute. Our area should be 0.05. Execute. Okay, so that should be 100.2 kilometres per hour. That's looking a lot better. 1 mark would be awarded for that part, and 1 mark would probably be awarded for entering this into the calculator correctly.